In this video we're going to do some geometry angle questions, and I suppose before we even look at the questions there's some important rules that you need to remember when you're doing these questions. And a very important one is that alternate angles are equal. Now what that means is alternate angles is where you try and find a Z shape. So if you look in this particular shape we've been given, you can see a Z shape in there hidden. There's a couple of Z shapes. Well, if we take the purple one to begin with, the rule is that the angle that's in there in the corner of that part of the Z is the same as the angle that's down here in the other corner down the bottom, and therefore out here is equal to out here. And then if you can also see another Z shape in there. If I just delete that little one that I drew, the purple one, and you can see another Z shape here, and the same rule would apply to the angle in the corner up here would be equal to the angle in the corner down the bottom. Essentially you're looking for Z shapes. The angles in there are equal, and the angle outside the Z shape, so if that line extended, that angle there would be equal to, if that line extended, that angle out there. Okay, and of course there's another Z shape in there as well, on the opposite direction. There's a sideways Z, and the same thing applies. That shape is just the same thing. Z there, there's another Z here. Okay, and you're looking for the corners of the Z's. Now can we apply that to this first one here, where we're asked to find A, B and C? Well, normally you'd always start off by finding A, so you do it in the order that they give it in. So A is normally the easiest one to find straight away, and you can see that A is part of a Z. See that Z shape there? So if that's 78, well then that's 78 as well. So you'd say A is equal to 78 degrees. You give a little explanation as to where you got that from. You'd say alternate angles. Okay, it's important to explain where you're getting your information from. Right, now we try and find what B is, because do it in the order that they gave it to you. So B is part of a triangle, this triangle here, and of course you know that the three angles in a triangle will add up to 180. We have that one, it's 28. We just found what that one is, it's 78. So finding B shouldn't be a problem. We know that 180 degrees is equal to B plus 28 plus 78. Okay, this is 78. So 180 minus 28 and minus 78 will give us what B is. So we just bring the numbers over onto the same side and leave the B where it is. So we know that, what's that, 90, 106 is 74? 74 degrees is B. So now we found what B is. And we can explain that by saying three angles in a triangle add to 180. Okay, we're just explaining where we gotten these answers from. So we found what A is, 78, by using alternate angles. We found what B is by adding up the three angles in a triangle. Now C. Now we try and get what C is. And C is probably the trickiest of them all. Well, in these shapes, delete what we these little symbols here now. So let me clear. In this shape here, this angle is equal to the opposite corner over here. So we found out that A was 78 already. And now we will be able to find what C is very easily, because you see that straight line there. All of that angle adds up to 180. Okay, it's a straight line, so the angle will be 180. So we know that 180 is equal to 78 and C put together. So that means if we take away the 78, we'll get what C is. We know that C is 102. Now, there was other ways we could have found C. Indeed, there's other ways you can find AB as well. You just use whatever way it gets you the answer in the end. We could have used the rule that says two internal angles of a triangle add up to the external one. That would have worked just as easy. But that's what A is, that's what B is, that's what C is. Okay, on to the next one. We rub these out so it's not getting confusing. And here again we have a complicated shape in which there are several Z shapes to see. But let's start by seeing if we can find what angle A is. Now hopefully we can get that fairly quickly. We'll do it in the order that they ask us to. Now there's nothing around it, so none of the other angles in the triangle are given. So we can't find it that way. So immediately see if you can find a Z shape. A Z shape. And you can see one here. We know from that alternate angle rule that the angle in the corner is equal to the other angle in the corner. So A is equal to, what is that, 32? Yeah, 32. How do we know? Because alternate angles. Let's explain where you got them from. Alternate angles. Okay, A is found. Now B. Let's see how we can find B. Can we get it from a Z shape? Always try and see if you can see the Z shape. So draw a line down. No, it's a backward Z, but it's still a Z. And you can see that the angle in the corner should be equal to the angle in the corner up here. So B will be equal to 62 degrees. And it's also because of alternate angles. Okay? Now let's delete this. So far, it mightn't be any harm just to fill in what we have. We know that this is 32, and we know that this is 62. Now, C. Let's move on to C. What will C be equal to? Well, if we just extend this line out here, we can see that all of this, because it's a straight line, all of it will add up to 180. So we know that C is equal to, well, we won't start by saying C is equal to, we'll start by saying 180 would be equal to C plus 40 plus B, which we know is 62. So that means 180 minus 40 minus 62 will give us what C is. So that means 102, 78 equals C. And what would be our explanation for that? We could just say a straight line. It's a straight line. It's part of a straight line. So that's how we found that. C. Now, is there any other letter? No, that's all of them. A, B, and C. Okay? So in this part, this one down at the bottom, let me delete this so we won't get confused. We have a similar shape to what we've been dealing with, but we also have these interesting little lines here put in. These little lines. Now these lines mean, these little notches mean that that side that they're a part of, so for this notch here, this side that it's notched on is equal to whatever other line has a similar notch. So in this case, all of the lines have a similar notch. So it means that all of these lines are of equal length. All of them. Now there's an interesting rule to remember in that when you have equal lines and equal lengths of sides, it creates equal lengths of angles to correspond to that. So that's important to remember in a moment. So let's start with finding what A is. So is there a Z shape we can use to find what A is? It's usually where I begin. So if I formulate this Z, that doesn't really help. Okay, so can I do a different Z this way? That doesn't help. This way. That's not helping. There's no Z's here that are helping. So can I try this? No, that's not a Z. Okay, the two lines have to be parallel to each other. Okay, and you can see that this one up here is kind of going in a totally different direction to that one there. So that's not going to help. So it looks like alternate angles aren't really going to help us for this. So we have to come up with some other method. And I suppose that's where these little notches are going to prove to be extremely useful to be aware of, because we need to break this shape up into different triangles. Okay, so if you look at this triangle here, these two notches that you see are very important, because it means that that red triangle that I've drawn, that's an isosceles triangle. Okay, it's an isosceles. Isosceles means it's got two sides of equal length. Those two sides. This side is equal to this side. And in isosceles triangles, the angle that's underneath those two sides of equal length, so that angle and that angle, they're equal. Okay? So 27 up here is the same as over here. So C is equal to 27. I know we're doing things slightly out of order here. We should try and find A first, but go whatever comes naturally. Now C is equal to 27 because of that isosceles triangle rule. Okay, I-S-O-S-C-E-L-E-S, isosceles triangle. Okay, so now I have what C is. I just jot it in. It's 27. Now, can I do something similar to that elsewhere in the shape? So, what about what I have? You'll often get these in these questions where you're constantly rubbing things out and drawing it again. So that's 27 down there at the bottom. Now there's another isosceles triangle. There's one. Which one will we do a bit easier? There's one here. Okay, that one there. Now, you see the notch here and here. That means that this angle is equal to this angle. Now, we're not asked for either of them, but it may be important in a moment or two. We see another isosceles triangle here. Now, this is equal to this. So that angle is equal to that angle. And this line that's coming down through the middle of them would mean that it's cut in half. Okay, so C would also be equal to this angle in here. So that's also 27. I know we're not asked to find it, but it may prove useful in a moment. So if we just took that green triangle out there for a second, just separate it off from the rest. This is something what it looks like. This, and B is here. This isn't given, it's not asked or anything. We don't know it yet. And we're told that half of this is 27. This is a line going through the middle of it. So all of it would be 54. Whoops. Two 27s together, so it's 54. And seeing as how B and A are equal, because they're both underneath this little notch, it means that 180 take away the 54, that gives you 126. If we divide that